Hello and welcome to Track Topper. In this video session, you are going to learn about elastic and inelastic collisions. So let's first talk about elastic collisions. An elastic collision is basically a collision in which both the momentum and kinetic energy are conserved. So that means they do not lose their kinetic energy. Like you can see here, two billiard balls when they collide, they then push away each other and they continue moving, and we expect that there is almost no loss of energy that has happened. It's just an interchange of energies might have happened, or the velocities have interchanged, but the overall kinetic energy and momentum remains conserved. So we would say the two equations that are valid for elastic collisions are, so if this is one body mass m1, its initial velocity is u1, and the other body has a mass m2 and initial velocity u2, then total initial momentum is going to be m1 u1 plus m2 u2. And if they interchange, or we say their new velocities become, say, v1 and v2, of course the mass remains the same. This becomes m1 v1 plus m2 v2. So this is about the momentum. The total initial momentum is equal to the total final momentum. And the second thing that is conserved here is also the kinetic energy. So if u1, u2 were the initial velocity, so what's going to be the kinetic energy total initially? That will be half m1 u1 square plus half m2 u2 square, and this has to be equal to the kinetic energy of the system, total kinetic energy of the system finally. So that will be half m1 v1 square plus half m2 v2 square. So you have to take care that though initial energies have changed, individual energies have changed, but the total remains the same. So whatever was the total kinetic energy before collision, you will have the same kinetic energy after collision. So if the collision is perfectly elastic, there is absolutely no loss of energy. Another example you can say, like when you throw a ball and it bounces back it bounces back up to the same height. Suppose you threw a ball down and it bounces back to the same height. That means it did not lose its kinetic energy at all. So that is known as a perfectly elastic collisions. Right? So let's solve a problem based on this. So here a question says that two balls of equal mass, they collide with each other elastically with the velocities shown below. So what is the velocity of the balls after the collision? It's clearly mentioned it is an elastic collision. So first equation for this will be, so I'll start with this, since it is an elastic collision, so therefore that means the momentum and kinetic energy both are conserved. So we have m1, which is m, times u1, which is 10, plus m2, which is also m, times u2, which is 5, is going to be equal to m1 v1 plus m2 v2. Here my m1 v1 and m2 v2 masses are same, but the velocities have changed, right? So this is what it is, and you can see your mass m is common throughout, so we can cancel it out. You have one simple equation, v1 plus v2 is equal to 10 plus 5, that's 15. That's your first equation. The other equation we'll get from the conservation of energy thing. So half m times u square, that is 10 square, is 100, plus half m times u2 square, which is 25 because its velocity is 5, and that is equal to half m v1 square plus half m v2 square. Again, half m is common throughout, we'll simply cancel it out, and we have the equation that v1 square plus v2 square is equal to 125. On solving these two equations, you would find that V1 becomes 5 meter per second and V2 becomes 10 meters per second. This is the case of a perfectly elastic collision where the two identical bodies, they interchange their velocities, right? So this is a perfectly elastic collision because identical masses interchange their velocities, which we can see in this case numerically, right? So that was a perfectly elastic collision because they interchange their velocities. Now let's talk about inelastic collisions. So an inelastic collision is basically that collision in which momentum is conserved but kinetic energy is not conserved. So the kinetic energy is lost, sometimes completely and sometimes partially. So in general, in this case, the colliding bodies, they stick together when it is a perfectly inelastic collision. So that means in a perfectly inelastic collision, kinetic energy is completely lost. Sometimes when it is just an inelastic collision, but we don't say it is perfectly inelastic, then partially kinetic energy is lost. So the only equation that is valid for inelastic collision is m1u1 plus m2u2 is equal to m1v1 plus m2v2. That's total initial momentum will be same as total final momentum by law of conservation of momentum, because whether it is elastic or inelastic collision, any kind of collision, the momentum remains conserved. But the problem here is that the kinetic energy is lost. But in this particular case, you know how this equation will change? You can see this is the first body, say its mass is m1, this mass is m2, this is velocity u1 and this velocity is at rest, so 0. After the collision, the bodies stick together. That means they will move with one common velocity. So when the bodies stick together, they move with a common velocity. So if I apply this to this situation, it becomes m1 u1 plus m2 u2 is going to be 0 is equal to m1 plus m2. They combine together and move with a common velocity v. So therefore it's very easy to find that common velocity v. It is equal to m1 u1 over m1 plus m2. So let's look at an example based on the law or the laws of conservation of kinetic energy and also on the conservation of momentum. So in this question, it says that if you consider the conservation of momentum alone, how much work is done to squash the balls in this example? So when we are squashing the balls, they are asking how much work is done. We know in squashing the ball, the kinetic energy has been lost. And that loss in kinetic energy is one which is going to give you the work done. So we'll simply start with this, that work done will be equal to the loss in kinetic energy. So that is equal to half M1, 100 grams is 0.1 kilograms. You can write it down. M1 is 100 grams, which is 0.1 kg. Its initial velocity U1 is 6 meters per second. M2 is 0.5 kg. Its initial velocity is 0. So half M into V square is 6 square minus the final okay, so afterwards we have the final kinetic energy. Because it is a loss, so I've taken kinetic energy initial minus kinetic energy final. So we have minus half times, now the mass is going to be 0.1 plus 0.5, they are together, so it is going to be 0.6. So that is minus half into 0.6 into the combined velocity is 1 meter per second, so 1 square. So we get, this is going to give us 1.8 minus 0.3, that is 1.5 joules. So this loss in kinetic energy is the work done that will be used up in squashing the balls. So 1.5 joules is your work done. Here we have one more example. A rail truck of mass 4500 kg moving at a speed of 1.8 meters per second. So I have a mass m1 4500 kg and an initial speed u1 of 1.8 meters per second. It collides with a stationary truck of mass 1500 kg, and since it's stationary, so its velocity is 0. Afterwards, once they collide, the two trucks couple together. Calculate the speed of the trucks immediately after the collision. So they want us to find V. I won't say V1 and V2 because they couple together, so they are going to move as one body. So just apply. We'll say by conservation of momentum. What do we get? By conservation of momentum, we get m1 u1, which is 4500 times 1.8 plus m2 u2, which is 1500 times 0, is equal to m1 plus m2 times the combined velocity v. So what do we get here? So we simply rearrange the terms. We would get, therefore, v is equal to what? 4500 times 1.8 upon 4500 plus 1500 is 6000. And solving this, we get 1.4 meters per second. So this is going to be the combined velocity of the two trucks coupled together. I hope it is clear how to use the elastic and inelastic collisions equations. That's all for this video session. In the next video session, you are going to learn about impulse. Thank you.